Siddhi, proceed please.
Good evening, everyone. Welcome to the Centenary Celebration of Department of Mechanical Engineering, IIEST Shibpur. I am Siddhi Suman, a third year undergraduate student of this institute and host for this evening. Today, we all are here for the 42nd lecture under the Centenary Lecture series, which is to be delivered by our honorable guest, Professor Prabir Basu, on the topic Global Climate Emergency 2022. Is Kolkata ready? This session will be chaired by Dr. Uttam Rana, who is Assistant Professor in the Department of Mechanical Engineering at IIEST Shibpur. I would like to invite Dr. Uttam Rana sir for the further continuation of the program. Sir. Sir, you can unmute yourself.
Thank you, Suman. It's my great pleasure to introduce Professor Prabir Basu to the audience of this 42nd Centenary Lecture series, Centenary Lecture of Mechanical Engineering Department of IIEST Shibpur. Professor Prabir Basu obtained his bachelor's degree in mechanical engineering from Bengal Engineering College, Shibpur. It was then under Calcutta University in 1967. He earned two PhD degrees, the first from Bardwan University in 1973 and the second from the University of Aston, Birmingham, UK in 1976. Professor Basu is going to deliver a lecture with the title of Global Climate Emergency 2022. Is Kolkata ready? However, there is a contradiction between the lecture title and the background of the speaker. Professor Basu, who grew up in the coal belt of Asansol, Raniganj, and then devoted most of his research and industrial career in developing clean coal technology, which earned him the prestigious Becura Townend Award of the UK for best contribution to the field of coal utilization in 1996. Realizing the adverse effect of coal combustion on the sustenance of our planet, he shifted to R&D on biomass conversion and finally dived into more pressing issues of climate change. A major contribution of Professor Basu is nourishment and worldwide propagation of CFB or circulating fluidized bed technology, where his fundamental research developed the cluster renewal model of heat transfer, and his industrial work developed the only Canadian technology of CFB boiler that was licensed to South Korea. He helped spread this clean coal technology through research, information estimation, training, and by authoring the first book on this subject. To recognize his contribution, the 13th International CFB Conference in Vancouver declared Professor Prabir Basu as the father and founder of this prestigious international series. On behalf of Canadian government, Professor Basu provided critical early support for the development of CFB technology in China, who presently operates thousands of such boilers and export the same to many countries, including India. To help Chinese engineers, he wrote the first Chinese language book on CFB boiler. Professor Basu brought this technology to India as well by building South Asia's first CFB boiler at Bhel, Trichy. Incidentally, he had B College involved in a similar Canadian-funded project in India. Before moving to Canada, he designed, built, and commissioned world's first biomass coal-fired fluidized bed boiler in Punjab in 1983. Professor Basu was visiting professor at MIT, director of Center for Energy Studies at Technical University of Nova Scotia and president of Greenfield Researching, a private R&D company that provided technology supports to industries in 8 countries around the world. He authored numerous journal papers and more than 10 books on coal combustion and biomass conversion, including translations in Italian, Korean, Chinese, and Persian languages. After retiring from Dalhousie University, he accepted the position of adjunct professor in Gulf University and is presently working on a new book on biomass conversion for climate changes. With this brief introduction, sir, I would request you to, I invite you to this lecture series and request you to kindly deliver your uh, lecture. Thank you, sir.
Kindly unmute yourself.
Can you hear me well?
Yes,
Good.
audible
Okay.
now.
Yes, sir.
Well, thanks a million, Professor Anna, for your very kind introduction. And I'd also thank the organizers for giving me an opportunity to share my scientific thoughts with my old school. The title of my talk is Global Climate Emergency 2022. Now, is Calcutta ready? The issue of climate change is evolving so fast that the prediction made today is not necessarily valid 2 years down the road. For this reason, I had to date stamp my talk. Now, let me see that if yeah. You can see that screen, right? Yeah, okay, all right. Uh, Before I begin, I would like to dedicate this talk to my grandchildren, Maya and Kaizen. This dedication not out of a parental affection, it's an obligation to their generation. Because the whole saga of climate change is essentially a war between two very unequal opponents. On one side is all-powerful our generation, on the other side is the powerless, young, or even unborn generation who are waiting to bear the burden of our actions. To satisfy our greed, comfort, and needs, my generation, which is Generation Y, has plundered the planet without any regards for the mother nature or the interest of future generation. Well, you might wonder why I blame my generation alone, not that of my parents and grandparents. Because over the last 30 to 40 years, we have vastly improved our comfort, lifestyle, and to do that, we have released more carbon dioxide to the atmosphere than our previous generation did over the last 300 years. For our grandchildren, we are set to leave this planet much too inhabitable for healthy, let alone comfortable. Now, the first part of the talk will discuss global climate emergency, and the second part will examine how these relate to your city, Calcutta or Kolkata. It is titled Climate Emergency because climate scientists are getting increasingly worried about Earth's future. They fear that the world is facing a danger that it has never faced for many thousands of years. And also, this danger may even lead to total extinction of all living species, including human beings.
Sir, sorry to
Finally,
interrupt.
yeah,
The screen is not visible right now.
but can you see me now?
Yes, I can see you, but your screen is that presentation is not
Sir,
visible.
are you presenting something? That presentation is not coming. You are visible.
I'm not presenting anything.
Okay. That is
I
what.
I will present only when I need it.
Okay. Yeah.
Okay. Yeah.
Yeah.
We can see you.
That's all right.
No, I got it. I got it that way.
I'm sure that all these thoughts are much too radical and scary for many of you. But
Mhm.
trust me, I too find it hard to believe or accept. But how could one dismiss these when every prediction the climate scientists made since 1990 were not only true, but they were more severe than they had predicted? The reality is that a scientific fact remains a fact, whether we like it or not. If we believe in science, we have to believe in the scientific method. Anyway, before getting into this topic, I would like to explain 4 terms which I'll be using. Number 1, the global temperature rise. Now, we often hear about temperature rise. Uh, mm, Now I'm sharing the screen. Okay, yeah. 1 degree, 2 degree, 3 degree rise. What is it? This rise is the rise in average land and sea temperature over the world above a reference level, which is the mean temperature during the period of 1951-1980. Please note that this temperature rise is by no means uniform around the world. As you can see from this screen, that the temperature rise in the Arctic on the top, they are reddish, which means they are much more than the rest of this. In fact, Arctic is hitting 2 to 4 times than that of the rest of the world. The next one term I would like to discuss is climate feedback loop. Now, the early climate models often underpredicted the impact of climate change because they did not take this factor into account. Sometimes an impact of climate change contributes to its very cause. That the impact is multiplied many times. We can see that when you bring a microphone of a sound system in front of the speaker, how the sound gets multiplied. So this is a climate feedback loop. Now, next one is a tipping point. Tipping point is defined as a threshold limit when crossed that will lead to large and often irreversible change. Please note the word irreversible. Now, let me explain that with an example. If you can see that if I tilt my chair backwards and release it, I'll come forward. But if I continue to tilt backward, and then when I cross a certain limit, I'll tilt over. I won't be coming back. And that's what is happening to these tipping points, which you see in this figure, that when the change exceeds certain amount, then it will, no matter what you do, it will not come back. So far, the IPCC has recognized 9 main tipping points. As you can see from the bottom, that each of these tipping points are associated with a specific degree of warming. Now, last one, which I will discuss, is tipping cascade. Here, one tipping point can give rise to a series of tipping points, just like a domino effect. Now, question is, why the scientists are so much worried? Because their work is revealing results. It was so scary. They felt it, unlike many other scientists, a moral obligation to the society to come out, inform the public, and urge for immediate action to save the planet. Last month, that's October 2022, more than 14,000 scientists around the world signed a declaration of climate code red for humanity. Do you know what code red is? Code red is generally declared in a hospital when a patient is in imminent danger of dying. The scientists called on all governments to immediately pursue massive-scale climate change mitigation adaptation. It also issued similar warning in 1992 and 2020, but not much was done. A recent paper, I will show you their concern. A recent paper published in the science journal Nature, here it is, that gives every indication of rapid climate change. These plots, I'm not going to details of those, that shows ocean heat is rising, ocean acidity is decreasing, sea levels rising, dengue virus is going up. So there is every indication of climate change and faster rate of climate change. Unfortunately, in spite of all the dire warnings of the scientists, and also the government's also pledging support in the event conferences, including the one that concluded last week, the carbon emission that continues to rise. As you can see here, this is a plot of concentration of carbon dioxide in the atmosphere. As we can see, from 300 ppm, it now well exceeded 400 ppm. As I speak, this in 2022, this has gone about touched 420 ppm. And as you know, there's a direct linear correlation between that carbon dioxide concentration and temperature rise on the world. So this is clear evidence that in spite of everything, the earth is warming. Now, if you look at the next one, methane. Here the story is even worse. Here we can see that methane is continuing in 22. The rate is higher. Now, methane is particularly troublesome, worrisome, because methane is 80 times more potent than carbon dioxide in the near term. And its increase that greatly worries the scientist. Now, let's discuss the issue of climate emergency. Okay, to do that, we'll first discuss what's the present status of climate change, then examine what lies ahead of us, and then explore how serious the threat of climate change is. Now, to show you the current state of climate change, I will share with you the graph of temperature. Here you can see this is a plot of global average, which is land and sea average, not the land, from early 1800. So as you can see, this is the reference point. We have chosen this as the reference. It is increasing. Right now, we are at about 0.86 degrees Celsius above the reference plane. Now, please note, this is the land and sea average. And the land temperature has risen by 1.4 degrees Celsius. And as a result of that, we see ice melting in most unlikely places. This photo which you see is Antarctica. Antarctica is losing ice at an enormous rate, 151 billion tons per year. It is a huge loss. Then if you look at in the north, the Greenland is also losing ice because peak temperature during the summer has risen up to plus 20 degrees Celsius this year. As a result, a massive amount of ice is melting in Greenland, about 280 billion tons per year, more than what Antarctica is losing. And if I go further north in the Arctic, we see that Arctic temperature has risen by 2.2 degrees Celsius. Please note the global average temperature right now has risen by 0.86 degrees Celsius, but Arctic has warmed by 2.2. It's more than 2 times the average temperature. As a result, Arctic is melting at a much faster rate. What you can see from the photograph is all molten. This is all supposed to be solid ice. And this graph shows the monthly average sea extent. This is the sea ice extent is continuously decreasing with the year. It is losing at a rate of 12.6% per decade. And possibly in the next decade or so, we might see an ice-free sea passage through the Arctic during the summer. Now, this tremendous impact, warming of Arctic has a very disturbing effect on the permafrost. This photograph taken in the high Arctic in a cemetery, as you can see that softening on the ground, which is supposed to remain frozen throughout the year, that has tilted on the cross. And this has a very devastating effect on the climate change, which I'll explain shortly. Now, beside these, we also have other things we keep hearing, like a drought, extreme weather, sea level rise. We'll escape those things and discuss only the near-term projection, that what lies ahead. So let's see that. Now, this is a graph which has been prepared by IPCC, which is the Intergovernmental Panel of Climate Change. Depending on what course of action we pursue, the temperature rise of the globe could follow different scenarios. For example, the blue line here, which you see SSP 1.9 is the most optimistic one. And in the conference, we are all talking about that. It is 1.9, where it will hit 1.5 and then drop to below 1.2, about 1.4 at the end of the century. The next best scenario here is SSP 2.6, which they say most likely. Here, it will exceed 1.5 and then it settles about 1.7. Now, United Nations has already declared that we have missed the goal of reaching 1.9, 1.5, which means this is no longer the case. We have already missed. We are probably moving along this trajectory, which will take us to close to 3 degrees temperature rise by the end of the century. But in any case, what I would like to stress here, that please note, irrespective of which path you take, the socio economic path, you have to cross the 1.5 degree Celsius in the near term, which is before, because 2030, 2040. So let's examine what will happen with a 1.5 degree warming. A recent paper that discussed this issue in great details. They said that a temperature rise of 1.5 degree, remember, Present rise is only 0.86 degrees Celsius. About additional 0.6 degrees Celsius will take us there. That will kick off a series of tipping point through the phenomena that I discussed earlier, is a tipping cascade. And tipping point, remember, is by definition is an irreversible event. That if certain things tips, it cannot, no matter, even if you suck all the carbon dioxide from the atmosphere, bring the average temperature by 10 degrees Celsius, still those impact will not be rectified. This is reversibility. So they said that earlier we have seen there are 9 tipping points, and the scientists predict with 1.5 degrees Celsius now, we will kick in on as many as 6 tipping points. So we'll discuss this in some details about those tipping points. Now, what is happening right now as we speak, that with only 0.86 degrees Celsius warming, ice in Greenland is melting 6 times faster than it did in 1990. Then the mountain glaciers are melting so fast that by 2050, 1/3 of all big glaciers will be gone. This is the scientists that determine. Incidentally, the melting of mountain glaciers agrees with a recent paper I read, which predicted large increase of water flow through the Ganges by 2030. That's quite likely to happen when the glaciers in Himalayas melt. That will increase the water flow through the river. And you can well imagine what will the consequence. So a warming by 1.5 degrees Celsius will accelerate the melting of Greenland ice sheet, and that will further push it beyond the tipping point. And when that happens, that will increase the sea level rise by 27 centimeters. Additionally, this melting of Greenland ice will pour enormous amount of water, fresh water, into the North Atlantic Ocean. And that will affect that Atlantic meridional overturning circulation, which is a critical circulation that has tremendous influence on the world's climate. Let me explain this one. Okay, here's a schematic of that. Here, this is essentially a thermohaline conveyor belt that conveys heat from the southern hemisphere to the northern hemisphere and keeping all these lands around this worm. And as it goes up, it loses on the surface water, evaporates, and then become more and more saline. And as it reaches near Greenland, it becomes sufficiently dense to sink down the great depth, and then turns and returns to southern hemisphere at great depth. So we have 2 layers. One layer going to the north, one layer returning to the south. And this way, this is able to transfer heat around the northern and southern hemisphere. Now, what is happening now, as you can see here, I'm sorry. Okay. As I mentioned earlier, that enormous amount of ice is melting here in Greenland and the Arctic Ocean. Those fresh water are mixing, and that reduces the salinity of the water here. And when the salinity is reduced, density is reduced. And this amok is driven by the density difference. So when the density differences reduces, hydraulic head is lost. So this circulation rate reduces. Already scientists predict, scientists determine that it has been reduced by 15%. But when there is a total stoppage, then it will have enormous impact on the whole world. That Northern Europe might plunge into mini ice age, and then northern seaboard United States can expect a high 20 to 30 centimeter rise in water. I don't know if you have seen the recent Hollywood movie, The Day After Tomorrow. This is the dramatization of the sudden collapse of Mech. Of course, it's not going to happen suddenly. It will happen over a period of time. When that happens, as I mentioned, there's a huge rise in sea level that will cover the entire, as the movie showed, New York underwater, and then followed by thawing. Followed by freezing. Everything, entire Europe and North America is frozen. So this is going to have a large impact on the ocean in North America as well as other places. Now let's look at the other one. What's happening down south in the Atlantic, in the Antarctica? In Antarctic, as you can see in the picture here, this ice rests on bedrock. And this ice sheet is very unstable. A small retreat could destabilize it and then slide over the ocean. Now, this sheet, ice shelf, towards the end, that effectively protecting the main body of ice back here. Now, currently what is happening, the warm water down below here is eating away or melting the base of the ice. As a result of that, the overhang is increasing, and beyond a critical limit, that is collapsing on its own weight. Recently, one big ice shelf that broke loose in a matter of a few months, and that saw 10 times increase in the loss of ice from the main Antarctica body. So this is a major threat. Presently, it's already adding about 0.22 millimeters per year sea level rise to the 3.11 current global rate. But if the entire ice of Antarctica melts, the sea level of our Earth will rise to phenomenal level of 60 meters. In fact, that has been proven by recent research who dug into the ocean floor. There's evidence of that happening few millions of years ago when the atmospheric carbon dioxide concentration exceeded 450 ppm. Remember, right now we are at 420 ppm. The next effect of this Mech stoppage, that further warming of the ocean. Because I remember I told you that Mech will stop transfer of warm water from the southern hemisphere to the northern hemisphere. When that doesn't happen, then this, instead of plus 0.4 degrees Celsius, it will even warmer. And these would be melting at a faster rate, and ice in the Antarctica will be lost even at a faster rate. But beside that, this will have another impact, because as you can see, this circulation is affected the entire globe. That rain belt, that is the tropical rain belt band that will move south. When it does that will have a severe impact on the monsoon cycle. And this area in the middle, which is a habitation of 1 billion people who depend on the monsoon, including India. If the monsoon rain is lost, agriculture will be lost. So that will have a tremendous effect on this. We can already see some effect on the Amazon rainforest. Amazon rainforest, as you know, was considered to be the lungs of the earth, absorb all the carbon dioxide. But it has seen 3 severe drought in the span of only 10 years between 2010 and 2020. And this is the drought which you expect to see once in 100 years. But this time is happened 3 of them in a span of 10 years. So large part of Amazon rainforest has turned like this. So as we speak, Amazon rainforest has turned into a net carbon emitter. It's no longer a carbon sink because of huge loss in the vegetation. Now, another important impact is the thawing of permafrost. Permafrost is a year-long frozen mass of organic materials, plants, and dead animals sits on the ground. This soil is very rich in carbon and microbes. Incidentally, this black stuff which you see here, this is the permafrost layer, that holds 2 times more carbon than the entire atmosphere holds right now. Now, rapid warming on the Arctic has already started thawing, which you can see from this photograph here. And they are making those frozen microbes active again. And these microorganisms, they feed on soil carbon and release methane. As you know, methane is 8 times more potent than the carbon dioxide. And this is possibly the reason why earlier you saw a rapid increase in the methane concentration in the atmosphere. Incidentally, this reaction of the microbes with the carbon, this is an exothermic reaction. That provide additional heat to the ground, and that further accelerate the process of thawing. So presently, scientists expect that permafrost thawing could add between 0.1 to 0.3 degrees Celsius to the present level of global warming. So as you can see, these are all tipping points. One is setting another one, and this cascade goes on. Next one is coral reef. Well, this one tipping point which has already happened at current temperature. You might wonder why the coral reef is so important. About 25%, that is 1/4 of world fish population, depends on the coral reef. And that supports as many as 500 million people around the world. And as I mentioned, as you can see from this picture, that this tipping point is already there, which means the large amount of areas of coral reef has already been bleached, including one, the Great Barrier Reef in Australia. You cannot put it back, it's gone. So what you saw here, that one tipping point set multiple tipping points, one after other, and all of them are likely to happen at 1.5 degrees Celsius, and some of them, including the coral reef, has already tipped. Now let's look at other aspect that which is irreversible aspect of this. The climate scientists are calling for drastic and immediate reduction in carbon emission, but certain groups do not share their concern. They argue, oh, well, in the next few decades, human ingenuity will invent means for sucking CO2 from the atmosphere and all substitute all fossil fuel with the cheap hydrogen. Oh, by 2050 we'll do that. Well, I'm not too sure of that. But anyway, even if we accept their optimism, we would have crossed the tipping point at 1.5 degrees Celsius between 2030 and 2040. What good is there in changing in 2050? Because the damage is done to the planets through the tipping points cannot be undone. For example, can we put the ice back on Greenland and Antarctica when they melt? No. Even if we reduce the carbon dioxide concentration to 100 ppm, still you cannot do that. So that brings us to the other concern the scientists had, which is extinction. This is a serious impact of 1.5 degree warming. Even with present extinction, warming of 0.86 degrees Celsius, as many as 892 plant and animal species are already extinct by 2020. With further warming, many more species will find it difficult to cope with the climate change. It is not the species alone. Humans are also affected. Between 1998 to 2017, about 166,000 people died just from extreme heat exposure, just heat exposure. Now, extreme heat exposure. Now, in Canada, 2 years back, we had a temperature rise of 49 degrees Celsius in one location in British Columbia, and that led to death of about 600 people. Why people die from heat wave? The reason is physiology suggests the upper limit of human sustenance is 35 degrees Celsius at 100% relative humidity, or 46 degrees Celsius at 60% relative humidity. Now, continued exposure to an ambience worse than this would lead to several complications, including death, because human body can no longer evaporate sweat beyond this to keep the body internal system cool. Admittedly, climate change may not lead to extinction of human race, at least in the near foreseeable future, but by kicking the food and water scarcity, it could threaten the lives of hundreds of millions of people, and which could in turn trigger societal collapse or even global conflict. Some of you may remember the heat wave in 2015 in India, where 2,500 people died, including some in West Bengal. In Kolkata, the temperature reached close to 40 degrees Celsius with high humidity. Now, this brings me to Kolkata because IPCC, they warned that this episode in 2015 could be an annual event in Kolkata if the global temperature rise to 1.5 degrees Celsius. So let's look at this temperature plot of Kolkata. This is the temperature plot of Kolkata. As you can see, there's a steady increase in the temperature in Kolkata. But and on the left side, we have future projection. So depending on whichever path you follow, that, for example, if you do nothing, that we just continue the business as usual, which is RCP 8.5, then we might reach the temperature rise of 5 degrees Celsius by the end of the century. If we do that, then in large parts of the world, the human sustenance limit will be crossed, which means people won't be able to survive. Now, before I get into the discussion of Calcutta, I must admit, I couldn't find much data on Kolkata in the archival literature. This could indirectly give me an idea of Kolkata's lack of awareness or concern about climate change or climate emergency. So I rely on information that my friend Shamal Karaoke, our resident, provided me, and I thank him for that. Kolkata, as you know, was built on a low wetland by the river Hooghly, but in mostly unplanned way. Though Kolkata had, being the capital of British Empire, a sewerage system first in Asia, perhaps just after London, but it didn't expand or improve in keeping pace with time or rising population. Additionally, the special bolt-up contour of Kolkata, which should high elevation near the Hooghly on the east, in the west, it makes it very difficult to drain flood water into river Hooghly. Additionally, the Kolkata has, as you can see from this landscape picture, a huge shortage of open area, lateral water bodies, which is less than 5%. All the red one is the built-up area. So that it has no room for absorption either rainwater or flood water. Where is the water? Because contour the Hooghly. So we cannot expect a natural drainage. So this has to be handled mechanically. In addition to that, Calcutta had another problem. Being situated in the river estuary Kolkata faced tidal bore, and which have already started flooding the both sides. This is a photograph of Belur Mount, which you can see here. This is the Ganga River. The water Ganga River is same as the land. And this used to happen once in a couple of years, but now it is almost an annual event. It is expected that this kind of flooding of the banks will be much more frequent. Now, Indian Meteorology Department has already declared South Bengal, which includes Kolkata, the most susceptible to cyclone, flooding, and extreme storm. So that brings two types of impact to Kolkata. And short-term impact, which is transient type, or long-term or permanent. The short-term impact, which we expect according to IPCC at 1.5 degrees Celsius, that annual occurrence of 2015 like heat stress. I'm sure some of you have experienced what happened in 2015, and you can expect that to happen every year. And also, number of days above 35 degrees Celsius, that is likely to increase to 181 days in a year, about half the time. And this high humidity and high temperature could make life unbearable with a greater number of deaths and sickness. Additionally, this would greatly increase the incidence of vector-borne disease in dengue. I gather that dengue is already affecting many places in India. I do not know about Calcutta, but certainly in other places. Now, this frequency of rain will increase, and that will, because the water cannot be absorbed, that will bring flood, and that will bring great deal of suffering in Kolkata. Now, tidal board is another problem because that is going to affect, like which I've shown here, and when that is added with the high sea level, that will increase much more place area. I'll show you here. As you can see here, this is a Climate Center prepared these things, animation or simulation, what is likely to happen in 2030. The tidal board and high sea level rise will drown good part of areas shown by red under 1 feet of water. Now, meanwhile, what is happening, that the Bay of Bengal is getting warmer and warmer, and that is giving birth to more frequent or more severe cyclone, and that will impact lower the southern West Bengal, Sundarban, and Kolkata will have its impact. Now, let's look at the long-term effect on Kolkata. Kolkata, IPCC already declared Kolkata as one of 8 most vulnerable coastal cities in the world, which is exposed to multi-hazard, not just one, multiple hazards. One of them is ground subsidence. Well, what is happening here, like in Jakarta and few other cities, large multi-story buildings are withdrawing enormous amount of groundwater, and that is leading to subsidence. As you can see in this picture, this shows about 6 to 100 millimeter subsidence per year. On the other side, coastal sea, that is rising at 3 to 10 millimeter per year. So as a result, the chances of getting more flood into the coastal city like Kolkata is increasing. And this is something which is typical for a lot of coastal cities like Kolkata. The original prediction that Kolkata will be submerged in the water in 2050. But faster pace of climate change may take Kolkata, according to more recent research, below the annual tide level in 2030. What is annual tide level? You know that during the annual tide, a combination of different tide, storm surge, that tidal board, the water rises. And according to that, by 2030, Calcutta will be below the annual tide level. And 2030, just only 9 years down the road. Now, we have seen that it is not that neighboring areas are all likely to be underwater. Now, this will prompt the long-term problem of climate migration, because people from Sundarban have already started migrating because Sundarban is going under sea. Goramara Island is already under sea, most of it. And the same thing's happening in Bangladesh also, because that Bangladesh is likely to be underwater, good part of it, by 2030, 2040. And that will create severe economic, social and political challenge for India. As you can see from this here, this land, most of it Bangladesh. And this migration population explosion will have a twin problem for Kolkata. Because Kolkata will receive large number of people from Sundarban as well as Bangladesh. Because 170 million people in Bangladesh, they have nowhere to go. The West Bengal is the only escape route for them. And West Bengal is already burdened, or was overburdened with the existing population of 90 million people. When added with the refugee of 170 million, you can imagine what is the situation. West Bengal has already seen the similar refugee problem at least twice in the past. This could throw formidable socioeconomic challenge to Kolkata as well as India. Well, question is, isn't there any hope? Well, answer is a bit complex. In one sense it is, but because human ingenuity has time and again fought against adversity and survived. We have recently seen how humans developed COVID vaccine in just 2 years instead of 10 to 20 years, and thereby saved the world from disaster. Now, this happened because the government were very proactive. This provided enormous support, and there was a strong financial incentive for the vaccine industries. Unfortunately, for climate change mitigation, one critical enabling factor is missing. The science has clearly established that the immediate substitution of fossil fuels with renewable is the only option to avert climate change disaster. But this move will directly hit the business interest of fossil fuel industries, who would be the main driver for action. Thus, one can expect a strong hesitation from this industry group. The last week, the World Climate Change Conference, COP27, concluded in Egypt, but the world body could not agree to a time-bound action plan, which was essential to avoid disaster that we talked about. So, what's the reason? Without going to socioeconomic aspect, which is not a part of this talk, let me just share you two graphs, and you can take your conclusion from that. Okay. On the right-hand side, you can see the subsidy the world governments are providing to the fossil fuel industries to keep the fossil fuel affordable and cheap. Look at the amount. This amount, $6,000 billion per year. And this is not my figure. This is a figure by International Monetary Fund, IMF. $6,000 billion per year subsidy given to keep fossil fuel cheap. Okay, now let me compare that with how much investment is made in the renewable energy. Yep, here it is. You can see by year, only $460 billion per year, which is less than one-tenth of what is kept to support the climate change disaster from fossil fuel burning. So I want to comment on that. I'll let you draw the conclusion from that. So my conclusion is the world is facing immediate danger of climate change, but inadequate efforts are being made to face the challenge. This could leave most parts of the earth largely inhabitable for our future generation. And Kolkata is in the front line of vulnerability. It doesn't appear to be ready to protect Calcutta residents from the seaborne impact expected in the next 10 to 30 years. An additional problem Kolkata has is the socio-economic challenges from climate refugees. It doesn't appear to be fully prepared to face the challenge. Well, thank you for allowing me to share my thoughts with you. And I will conclude with that.
Thank you, sir. Thank you for your excellent eye-opening lecture. I think the session is open for interactions. Please. Am I audible?
I can hear you.
You are.
Sir, Kolkata has a natural slope towards Salt Lake City, right?
That is correct.
The water goes towards the
Yes.
Salt Lake City. And
Yes.
some 6 months back, I read one article which says that Salt Lake, in fact, it is the fact, well-established fact that Salt Lake City, that water bodies has a natural cleaning system. Whatever dirty things goes, it has a cleaning abilities. So that way, it has helped Kolkata for many years to provide fresh waters. But
Yeah, that's
Salt Lake City is also,
yes, that's very
Salt
true.
Lake City is also being covered with lands, and it is
Yeah.
high-rise buildings are coming.
Yes, yes, it's true.
So the session is open for interactions.
I have a question. Hello, can you hear me?
I can hear you.
Yeah, this is Pradeep Saha from Raleigh, North Carolina. I'm a 68 BE college graduate. Pravidda, I met you long ago at CMERI and other places. You may or may not remember me. Anyway, a few weeks ago, I gave a lecture, this centenary lecture on nuclear
Yes.
power, and I did touch upon, not as detailed as you have done, about the climate change and going away from the fossil fuel, and of course, nuclear is one component. Now, one problem that I see, and you have mentioned that, because 10 years ago, I participated in a workshop, in an US European workshop in Italy about this climate change. And I noticed that the Europeans are much more serious about climate change even 10 years ago compared to US. And US, of course, unfortunately, when the administration changes, the policies also change. And so last administration took US out of the Paris Convention, etc. The present administration has brought them back. So there is always this fight between, there are certain states in America who are very much coal dependent. And the senators from that state always oppose anything to reduce subsidy to fossil fuel, etc. So considering all this thing, what do you think? I mean, it is, some of the people, at least one third of the people in United States, they don't believe in this climate change because it is not affecting them yet. So the question is that how can we, the UN or the world body, they have no power to sanction anything because all these veto, strong countries with veto power, they will always oppose things. So the question is, how do you, and it's a slow process, I understand that, and what you have shown, it is beautiful that things are irreversible. Once the Arctic Ocean, the ice melts, there is no way to put it back. So I do not know how to tell the countries to stay in course? You have any suggestion? Because I know about this international body. I also took a few slides from that body, IPCC, something like that. I
IPCC.
forgot. Yeah. I also took 1 or 2 slides from them in my talk. So how do you explain to the governments, particularly the powerful governments and populous governments who produce really more greenhouse gases, that this is something not confined into national boundaries. It is going all over the world. And if you do not do things, your people will also be affected someday. Maybe not today, but 20 years from now or 50 years from now. How do you have a consensus, a world international consensus about this climate change and reducing the greenhouse gas emission? Your thoughts.
My thoughts is the blame squarely lies on the public, like you and I. The science and economics are very clear. Science has clearly established the relationship between global warming and fossil fuel burning. Economics has clearly established that it is considerably cheaper to produce electricity from renewable energy sources than from fossil fuel. If you take out all the subsidies, that even now, the electricity from the renewable energy sector are considerably cheaper. So both science and economics are in favor of the change. But why the governments are not able to override the fossil fuel industry interest? The reason is the people like you and I are not concerned. We heard the things, but you don't believe in it. If we believe in it, we would act. Just to give an example, we had an election in our province 4 months back. There only 15% of the population polled showed climate change is their priority. I do not know if we have a similar poll in India in the election, but in the United States and around the world, well, public opinion shows still climate change is not the top priority. So if the public really wants it, government will change and they will force do it. So I will put the blame on us, we, the public.
But probably as of till now, it's primarily, I mean, one side you have only the scientific community. On the other side, you have the people who matters. Like for example, you might have heard very recently we had this climate denial or climate emergency denial declaration signed by some 1,100 VIPs, I should say. Many of them are senators in different countries. So there is, I mean, lobbies and counter lobbies, and this push-pull situation, the people on the side of climate emergency are only the people who represent scientific community. All other on the other side, including the people who have money, who run the governments. Perhaps that is the situation. That's why, I mean, probably one day it's only this scientific community along with the public force that is going to change the governments for the better. And the young people, voices from young communities are, I mean, day by day, they are coming up. These days, everybody knows who Gita Thanwag is. Five years back, nobody knew. So things are changing, but it's because nobody is promoting, and no big house is promoting. So therefore, perhaps, I mean, it's unequal war, if I may mention that.
Well, only thing I can say that we are gone past those phases.
Yes.
Nothing can stop us from sliding into 2015 situation which we experienced in Kolkata. It's going to happen. You can at best do to reduce the impact, but we are going downhill. Nothing can stop because the window of opportunity has already closed. I'm sorry to share this frustration, not frustration, but the pessimistic view, but this is reality.
But probably yes, Pradipta, please go ahead.
No, sir, myself, Santanu.
Oh yes, Shantanu. Yes.
So basically, sir, every scientist, basically climate scientist, is talking about this global warming, but there are many scientists also. Recently, Freeman Dyson, who is recently passed away, he never believed or in this climate change because he was mathematician and a physicist of high caliber, but he did not advocate for climate change, but rather he says that he does not believe in that. And also he uh, don't like did not like the that attitude of the climate change lobbyist. That who this Greta Thunberg, they are good, but basically when they are talking about, they think like this moral high ground thing, and then but they are talking from the richer country, so they don't understand that the poor country, they never are there to blame for these things. So what to say about all those things, this conflict?
Well, I cannot afford to get into debate of climate denier because those are well past that stage. But I would like to answer one good aspect, that it is the less rich country who stand to benefit most from climate change action and who stand to lose most from climate change inaction. Because the impact of 3-degree rise temperature in Kolkata will be much more severe than 3-degree temperature rise in Toronto. And then food sources will be, if it is strained, they will affect less developed country much more acutely than it will affect that richer countries. So, and on the other hand, that enormous opportunities there to capitalize on the new technology of which is called green technology. And for example, India made a tremendous stride in the field of solar energy. Solar energy is now considerably cheaper than energy produced from coal, oil, or gas. So countries like India stand to benefit tremendously. It is just the energy production. Another thing, for example, switchover, rapid switchover from the petroleum-based transportation to renewable energy-based transportation. That give a tremendous boost for the engineers like you and I. New technology, new manufacturing, and China had made best use of this option. They saw tremendous growth in the employment. If India chose that path instead of living behind the old technology, they can also increase the employment for newer generation of engineers and the people, at the same time save the planet from climate disasters. So to answer your question, the less developed countries stand to gain more from climate change action and stand to lose more from climate change inaction.
But that also, sir, for this transition in the COP 2027, India has placed a document that it will go to carbon neutral like this zero to projected to 2070. For that, actually
2070,
for
yes, that's far away.
actually for transition also we need fossil fuel, because without fossil fuel we cannot transition from this to this green energy, this current to this, and who will, for rapid change we need that much of investment. And this in COP 27, this richer country are not going to invest in the country like us, India or China. Now China, they will not invest in China because China is already in competing with the US, but they are not also going to invest in India or similar country like though. What to do basically?
Why should India need external investment if you remember the figure I showed you? You can Google the figure for the fossil fuel subsidy given in India. That's a huge amount. If the government put that money into renewable energy, they can make the switch over much faster. Because even if you calculate the capital cost investment per megawatt generation, the solar or wind takes much lower investment than a coal-fired power plant. So you can do it. If you want to do it, you can do it. So all you have to do is to take a proactive approach and not depend on others.
We are trying to take a position, probably, as if showing we are, I mean, aggressively pursuing renewable energy technologies. That's also true. You cannot deny. But then on the other side also, we are promoting coal-based plants. We are promoting oil-based systems. So we are defeating ourselves probably, and that is why we could not commit. We are keeping a 50-year window for coming down to that level. 2070 is far away, and in fact now probably they are asking for greenhouse cut of 7% every year for 20 or 30 years now. That's what the IPCC is projecting.
In this COP
Every year you have to cut 7% emission, or 6.7 or 7.6 something.
in COP 227, China also opt out from this blame of that who is to blame for this climate change. In G20, India and basically China also opt out. That basically they are not going to take blame for this climate change. Not only India, basically in China also.
No, that will remain. That per capita or per country basis responsibility, I think that is going to remain. All these populous countries will say we will go by per capita thing. These will say why per capita. Let's go for an overall emission. This will remain probably. But the fact remains we are going to tip, as Professor Basu was showing, at 7 or 9 places we are already over the tipping points. And the things are apparent quite.
If I may just add a little, I think there are two issues that I see. First of all, earlier, 10 years or 15 years ago, we used to call only global warming. Then it changed from global warming to climate change. And I think in general, people do not understand what global warming, okay, everything is getting heated and all that. What is the connection between that and floods and other things? That I think scientists did not, to my point of view, did not explain it well, or explain it which the common people understand. That's one issue that scientists have to explain the connection between global warming and climate change and greenhouse gas emission. Okay, that's one thing. Another thing is, since we are talking about things which will happen 30 years from now or 40 years from now, the people who are powerful, they are usually say 60 plus, they don't care. So it is correct that the young people, if there is a referendum, like in US, in many states, there were a referendum on abortion, but there is no referendum, at least in the US that I know of, on climate change. On when we go for voting, there is no clause that, okay, do you support my investment for renewable energy? There is no such thing here, at least. And other countries in India, and probably common people have no say. Basically, they go and vote either for one party or other party. And so it is the young people. I agree with Prabir that young people must be more forthcoming, because it will be their life. They will be in mid 40s or mid 50s or 60s when this climate change will really hit hard. So these are my 2 points. Any comment on that?
I agree with you that whatever we do today will affect our future generation, and future generation have to take the leadership, and unfortunately we are not allowing them to take the leadership. So it's a very unfortunate situation. Again, I repeat the same thing. Let's forget about the developed countries. We'll stop, setting our agenda based on what developed countries are doing. Looking at newly developed countries, we stand to gain most by adopting climate action, new technologies, and we stand to lose most not doing that. So there lies the fact.
Yes, the change is very fast. In fact, now across the globe, people are experiencing you see the increased frequency of this climate extreme weathers, extreme weather situations. People everywhere experiencing some way or the other. Yes, people. I mean, located at this part of the globe, yes, they will be the first sufferer. That's true, and that is why perhaps we only country that we have seen where leadership went ahead to push for this climate action. That was this Maldives only, because they were at stake. Maldives is going to be vanished, and that's why President Nasir, when he was president, he took. I mean, that's why he was recognized that way as a climate warrior. And no other country head or government head took that much initiative. So it's people only look at their own population. That is true, perhaps hard facts.
The problem is for the people, common people, is that when they see those elites who are talking about climate change, they don't follow the lifestyle what they're supposed to do. Basically, in Kolkata, people go to the suburb area that you should not use AC, but in Kolkata, there are people every year the AC number of ACs are increasing. So why can't they reduce AC? That ban ACs from all the houses. Live the life of what the people of suburbs are doing, living. If they are not living by that what they are talking, then how are the common people going to understand that what they are talking is basically not basically going with their lifestyle? So then they will not never understand or never realize.
Perhaps
Yeah.
that needs a system in place.
No, sir. The situation has to be conditioned from the very childhood. Probably that will work. So
System
from the
culture.
very childhood, the consequence, as Dr. Saha was talking, that scientists are doing research work. They knows what is the consequence. Probably we cannot communicate to the common people, right? So the consequences of climate
Look at the
changes should be communicated in much more simpler language so that even the child can understand it, and it comes to their mind. So,
but policy pushes do not come from the people. It comes from the government.
when policy
Let's say
pushes doesn't work,
we are
it
talking
will
about
come from the
Kolkata.
common people.
We are talking about Kolkata. Is there any policy push for cycling within the city? In fact, that is prohibited. Where it should have been the reverse. In Kolkata roads, you cannot cycle. You will be taken out if you are cycling on the main road. And some European cities are.
My approach will be a little bit different. Instead of trying to ban air conditioners, instead of trying to ban car on the road, I will try to produce electricity from renewable sources and stop coal-based electricity. If I produce electricity with a rooftop in my building and use the electricity to run my air conditioner, what's the harm in that? There's no harm.
No, there is a point in air
I'm just taking an example.
you utilize.
For example,
Air
that
conditioning
if I
it's a spiraling effect. Because
if I ride a electric bike instead of a petrol bike, and that electricity comes from renewable source, what's wrong with that? So instead of trying to stop the usage, we try to modify the technology or the source. That would be my approach. Any other question?
Okay, if there is no other questions.
Then Chair, kindly allow me to.
Yeah. Thank you, sir, for your enlightening lecture. In fact, this kind of lectures are very pertinent in today's scenario, and we should discuss more and more on that. But due to restrictions of time, we have to conclude this session. I would request our HOD, Professor Ghosh, to do the formalities and present the vote of thanks. Thank you.
Well, thank you. On behalf of the department and on behalf of the Centenary Celebration Committee, let me thank Professor Basu for this enlightening talk, for taking time off from his busy schedule to give this nice lecture, joining this Centenary Lecture series. This is going to be the last lecture of the series. So it's nice to conclude a session with Professor Basu's lecture. Thank you, Professor Basu, for making your time. Yes, there is this soft copy of the certificate that we will be sending through email. Kindly accept this. We will also have a hard copy of the same along with the memento, which we will arrange to hand over somehow, either to you or to your representative. If you could give any local address within Kolkata, that will be fine for us, that we could make home delivery. So
I'll give you local address. And one quick question I have: when do you expect to put it on the YouTube?
And this, today itself we will get these things. In a couple of days, it will be ready. We will upload on YouTube, but we will hold it, and we might send a link to you. But since we have already approved it, we might just formally send you the email and put it into the YouTube. But still, if you have something in there, you might hold us back.
No. You can just put it on the YouTube as it is.
So you can do that. So in 2-3 days time, it should go into the YouTube.
Okay.
If you visit the website, you should find all the YouTube, all the links are there. In fact, we also made a channel where we also made a playlist within the YouTube. So one by one, things will keep coming. So that's a good thing, and that is going to stay there in the YouTube channel. So, and I must also thank Professor Rana for chairing today's session. Thank you, Professor Rana. So many senior members of alumni, Pradip Da, Alok Babu, many senior members of alumni have joined today. So thank you, everybody. Anjanadi is also there. Thank you, everybody.